Hello again. Let's continue from where we left off. Next question is, if the kinetic energy of a particle is doubled, then its momentum will. So, we have seen that momentum is equal to 2mk. If kinetic energy is doubled, then momentum will become under root 2 times. Okay. So, if kinetic energy is doubled, the momentum will increase by under root 2 times. Next question, if a force F is applied on a body and it moves with a velocity v, the power will be. So, it is a very simple question from definition. If constant force is applied on a body and it is moving with velocity v, then power is equal to Fv. It is a definition. Next question, a body of mass m accelerates uniformly from rest to v1 in time t1. As a function of time t, the instantaneous power delivered to the body is. So, body starts from rest, it starts from rest and attains a velocity v1 in time t1. So, naturally or clearly the acceleration is v1 upon t1. Now, if this is acceleration, then the force acting on the body is mv1 upon t1, and in general the velocity at any general time t will be again from first equation, v is equal to u plus at. So, at any general time t, the velocity is at and a is equal to v1 upon t1. So, it is v1 upon t1 into any time t. Now, power, this is velocity at any time t, this is force acting on the body, the force is constant. Now, power, the instantaneous power is again this relation force into velocity. So, m v1 upon t1 into v1 upon t1 times t. So, this is m v1 square upon t1 square into t. So, this is the last option. Next question. Water falls from a height of 60 meter at the rate of 15 kilogram per second to operate a turbine. The losses due to frictional forces are 10% of energy. How much power is generated by the turbine? So, let us calculate how much power is delivered to the turbine. So, potential energy at height h is mgh, and rate of change of potential energy will be power. Rate of doing work is power, rate of change in energy is power. So, power will be rate of change of this. Now, g and h are constant. So, g and h, and mass is changing with time. So, power will be dm over dt into gh, and the rate of power, water falls from height of 60 meter at the rate of 15 kilogram per second. So, dm over dt is 15, g is 10 and h is 60 kilogram. So, total this is 9,000 watt. Then 10% is lost due to frictional forces. So, 90% is left, 90% is delivered, turbine converts 90% of this into some useful form of energy. So, power generated by the turbine, say P dash, will be 90% of this. So, 9,000 into 90% of this. So, this is 8100 watt, 8100 watt, or you can say this is 8.1 kilowatt, 8.1 kilowatt. Next question. Next is, an electric pump is used to fill an overhead tank of capacity 9 meter cube kept at a height of 10 meter above the ground. If the pump takes 5 minutes to fill the tank by consuming 10 kilowatt power, the efficiency of the pump. So, it takes 10 kilowatt power, and how much power it generates will be efficiency. Okay. So, the ratio, the efficiency will be power generated divided by power taken into 100. So, we can calculate how much power it generates. So, it has to fill an overhead tank. Its capacity is 9 meter cube. So, mass of the water in this tank will be density into volume. Density of water is 10 raised to the power 3, capacity is 9. So, 9 into 10 raised to the power 3 kilogram water is contained in the tank. Then work done, this much power has to be taken to this height, and height is 10 meter. Then work done mgh upon time. If this will be the work done and time taken is t, then work done by time, work done by time is power. Now, mass is 9 into 10 raised to the power 3, g is 10, and height to which the water is to be taken is 10, and time is 5 minutes. So, 5 into 60 seconds. Then it becomes 5 into 6 is 30, and 0 will be cancelled, and 3 into 3 9, then 3 into 10 raised to the power 3 watt. So, power generated by the pump is 3 into 10 raised to the power 3, and it has taken power 10 kilowatt. This is 3 kilowatt and power taken is 10 kilowatt, then the efficiency will be 3 upon 10 into 100. So, this will be 30%. So, the efficiency of the pump is 30%. Next question. A body of mass 2 kilogram is projected at 20 meter per second at an angle 60 degree above the horizontal. Power on the block due to the gravitational force at its highest point. So, at some point, that means the instantaneous power at that point, then you know in projectile motion at highest point the velocity is horizontal. The velocity is along the horizontal, and force acting at any point is downward. So, force and velocity are perpendicular, and actually the power, the instantaneous power is the dot product of force and velocity. If they are perpendicular, then the dot product will be 0. So, power delivered by the gravitational force at the instant when the object is at the highest point will be 0. Next question. A body is initially at rest. It undergoes one-dimensional motion with constant acceleration. The power delivered to it at time t is proportional to. Now, the acceleration is constant. Now, if acceleration is constant, then force is also constant, and force is constant, and velocity at any time will be at if it starts from rest. Then power is force into velocity. So, F into A into T, F and A both are constants. So, power will be equal to F into T, or power is directly proportional to T. So, T raised to the power 1. Next question. When two spheres of equal masses undergo glancing elastic collision with one of them at rest, after collision they will move. So, this is the case of two-dimensional collision or oblique collision, and a piece of information is missing from the question. It should be the state of the affair is that a block of mass m is moving and it collides with another identical block which is at rest. Then they move in different directions. So, we do this calculation in our classroom. So, after calculation it comes out that they always move perpendicular to each other. Okay. So, when two spheres of equal masses undergo glancing, that means oblique collision with one of them at rest. Okay, I thought it is not given that the other block is at rest. So, now it is complete. The other block is at rest. This is the condition. So, one block is hitting the other one, other identical one which is at rest, then both will move perpendicular to each other. We do this calculation in our classroom. Next question, three objects A, B and C are kept in a straight line on a frictionless horizontal surface. These have masses m, 2m and m. Let's make a diagram. A, it has mass m, B, it has mass 2m, and C, it has mass again m. On a frictionless horizontal surface they are kept. These have masses m, 2m and m respectively. The object A moves towards B with a speed 9 meter per second and makes an elastic collision with it. Thereafter, B makes completely inelastic collision with C. All motions occur on the same straight line. Find the final speed of the object C. So, A collides with B elastically and B collides with C completely inelastically. So, you have to find the final velocity of this combination or C, same thing. Now, we can calculate the velocity of B after A hits it. So, from formula we know if this is at rest, then the velocity of B will be 2m A and velocity of A divided by m A plus m B. Now, this is m, so 2m, and this velocity is given as 9 meter per second, 9 meter per second. So, 2m into 9 divided by m plus 2m is 3m, mm gets cancelled, and 3 times 9, so 3 into 2, 6. So, B will start moving with a speed 6 meter per second. So, B hits C with a speed 6 meter per second and then they move together. B and C move together. So, we can calculate this speed. Then from conservation of momentum, initial momentum 2m into 6, 2m into 6, and final momentum will be 2m plus m into some v, that is 3m into v. Now, mm gets cancelled and 2 times 6, so v is equal to 4 meter per second. So, B and C will move together with a speed 4 meter per second, or C will move with a speed 4 meter per second. Same thing. A shell, next question, a shell initially at rest explodes into two pieces of equal mass, then the two pieces will. So, if a body is at rest and it explodes, so initially momentum is 0, finally momentum has to be 0, because the forces causing the explosion are internal forces. So, internal forces cannot change the value of momentum. Momentum has to be conserved if there is no external force. So, a body explodes into two equal pieces, then one piece will move, the two pieces will move in opposite directions. If one piece goes towards right, the other will go towards left, okay, so that the momentum is again 0. So, if a piece explodes and this goes towards right, m with velocity v, then the other piece has to go opposite to this direction with same momentum, so that when you add these two values vectorially, it is again 0. So, the other piece will move with the same velocity in opposite direction. Same velocity because the two pieces are of equal mass. Next question. A ball is thrown vertically downwards from a height of 20 meter with an initial velocity v naught. So, a ball is thrown vertically downwards. So, ball and height is 20 meter. So, this height is 20 meter and it is thrown with some speed, say v naught. V naught. It collides with the ground, loses 50% of its energy in collision and rebounds to the same height. The initial velocity v naught, how much is this v naught? We have to calculate. So, the ball hits the ground, it rebounds, and in this process it loses 50% of its energy. So, we have to calculate what is kinetic energy here. Before hitting the ground, the ball has some kinetic energy and potential energy will be 0 with respect to the ground. So, let us calculate kinetic energy. So, before that we can calculate velocity here from third equation, v square is equal to u square plus 2gh. Okay. Now, v square means the initial velocity is v naught square plus 2g and h is 20. So, we can put the value later, the value of h. So, before hitting the ground, the ball has velocity this much, then kinetic energy is half m and v square. which is V naught square plus 2gh. Now 50% of this, it loses 50% of its energy, so 50% of this will be half. So 1 by 4 m, half times this, that is 1 by 4 m V naught square plus 2gh. Okay. And the ball, after striking the ground, the ball goes to the same height. So when it comes to rest, the height is again 20 meter. So potential energy here will be mgh with same value of h here. So it is equal to, now whatever kinetic energy here, which is 50% of the kinetic energy before striking, whatever kinetic energy here, it will be converted into potential energy here. So potential energy here finally should be equal to kinetic energy after striking the ground. So 1 by 4 m and V naught square plus 2gh should be equal to this mgh, m and m gets cancelled, and 4 into 2 is 8. So V square plus 2gh is 8gh, or V square is equal to 8gh minus 2gh is 6gh, 6gh, 6 g is 10 and h is 20. So this becomes we have made some mistake in our calculation. V square plus 2gh, so kinetic energy is half m square of the speed, which is V square plus 2gh, and 50% of this 1 upon 4 m V square plus 2gh, and kinetic energy here is equal to final potential energy so 1 by 4, oh sorry, there is no 2, it was m, I thought it is 2. Okay, so it is not 8 but 4 gh, 4 goes here, so 4gh minus 2gh is 2gh, so 2 into 10, that is 20 into 20 is V square, so V naught is 20 meter per second. Okay. So the speed with which the ball was thrown is 20 meter per second. Next question. Next question. A shell of mass 20 kilogram at rest explodes into two fragments whose masses are in the ratio 2:3. The smaller fragment moves with a velocity of 6 meter per second. The kinetic energy of the larger fragment. Now the total mass is 20 kilogram and it is broken into two pieces of masses 2:3. So it is very simple. We can find that the masses are 8 kilogram and 12 kilogram. The ratio is 2:3. Okay, this is very simple. So one piece is of 8 kilogram, the other piece is of 12 kilogram, and the smaller fragment, the velocity of this fragment is 6 meter per second. Then the velocity of this fragment from conservation of momentum, momentum in this direction should be equal to momentum in this direction. The two pieces will be moving opposite to each other. So 8 into 6 should be equal to 12 V, or V should be equal to 8 into 6 divided by 12. So 8 into 6 divided by 12, this is 4 meter per second. So the heavier piece is moving with a speed 4 meter per second. Then the kinetic energy of the heavier piece, the larger piece, is half m and V square. This is 16. So this is 96 joule. So the kinetic energy of the heavier part is 96 joule. Next question. next question. A particle of mass m moving in the x direction with speed 2v is hit by another particle of mass 2m moving in the y direction. So, there is a particle of mass m, it is moving along x axis with speed 2v, and another particle which is moving along y axis, mass of the particle is 2m and it is moving along y axis with speed v. If the collision is perfectly inelastic, the percentage loss in the kinetic energy during the collision is close to. So, this collision is completely inelastic, that means the two blocks or the two particles stick together after collision. Then momentum has to be conserved. This is very clear. Momentum is conserved in all types of collisions. So, from conservation of momentum before the collision, you can take the resultant 2 mv along x axis and again 2 mv along y axis. So, resultant momentum is 2 root 2 times mv. One is along x axis, the other is along y axis, same value. So, take from the formula, the resultant is 2 root 2 mv. Now, so resultant will be in some this direction, Then the common speed, we can calculate the common speed. Now, both are moving together. So, mass will become m plus 2m, 3m, and let us say speed is v dash. So, 3m v dash, final momentum should be equal to initial momentum. So, 2 root 2 m v. Now, mm gets cancelled and v dash is equal to 2 root 2 upon 3 into v. So, speed of the combined mass is 2 root 2 upon 3 into v. Then you have to find the loss in kinetic energy. So, in fact, it is percentage loss in kinetic energy. So, how do we calculate percentage loss? First, we calculate loss. Initially, the value is more. So, initial minus final is loss upon the initial value into 100 is percentage loss. So, initial kinetic energy is kinetic energy of this block plus this block. So, half m into 2v square. So, it is 4v square plus half and 2m and square of v. So, v square. So, this is initial kinetic energy minus final kinetic energy. Finally, the velocity is this. So, final kinetic energy is half into 3m, half into 3m and square of this. So, it becomes 4 into 2, 8, 8 upon 9 v square, 8 upon 9 v square. So, initial minus final, that is loss, upon the initial value, this is the initial value. So, we can take the sum 4 times half mv square and 2 times half mv square. So, this is actually 6 times half mv square, okay? 6 times half mv square, 4 times half mv square and 2 times half mv square. So, this is 6 times half mv square, the initial value of kinetic energy. Now, half mv square gets cancelled from everywhere, half mv square, half mv square, half mv square and half mv square. So, we are left with 4 plus this 2 minus half mv square, 3 into 8 upon 9. So, this is 8 by 3 minus 8 by 3 and whole divided by 6. So, this is 6 minus 8 by 3, which is 18 minus 8 by 3. So, this is 18 minus 8 is 10 by 3 into 6 into 100. You have to calculate percentage. So, this is 18 and approximately this number will come out